Son of a gun. Okay. So you can see the schedule. Okay. There's the schedule. Test in Chapter 9. Now, 5-5 is a Thursday, Cinco de Mayo. We're going to review for the final. Now, how I'm going to do that is I'm going to give a sample final. Okay, I'm going to pass it out to you. You will do it. You'll bring it up to me. I will correct it. Okay, and then I'm going to go over it for those of you that need me to go over it. Because if you do well enough on that sample final, you won't have to take the next final. Okay, you do well enough in the sample on 5-5, you can be done. All right. Otherwise, on 5-9, you take the final, which will look very similar to the one on 5-5.
The final is going to be cumulative, right?
Yes, it is. Okay, and you'll see that on this final exam on 5-5. Basically, what it is 5, 6, 7 or so questions from each of the chapters that we covered. Okay.
When you say if you do well enough, what's that?
What that means is when you take that that sample final on the 5th, I'll have a final exam score. I'll have your 4 test scores. I'll have your 4 lab scores. I'll have your homework score from WebAssign. I will look at those scores and say, this at this moment is your grade. If that is acceptable to you, you can be done. If it's not acceptable to you, you have some options. You can boost your homework score, for example, on WebAssign. Or you come in the next class and take the final again.
If you do worse on that final, do we keep the...
I'll keep the original.
Is it worth 2?
What's that?
2 tests for the final?
2 tests, yes. Yes, and I'll take the higher of the 2. Yes?
What's the format of the final?
It's multiple choice, 25 multiple choice.
No, I mean, is it weighted for 2 tests?
Yes, it will. It's weighted for 2 tests, absolutely. Yep. And then what also, so here's the deal. You have the 4-hour exams, you have a homework score, you have a lab score, and you have a final score. There's 8. I'll drop the lowest of those 8 scores, whatever one that is. Add up the other 7, divide by 7. Okay, and I can tell you what your grade is based on that. So that's the rest of the semester here. Okay? Everybody else sit on this? That's what we're going to do. Now, hopefully we get no days off here and unexpected days off with water mains breaking or unexpected snowstorms or something, because that would wreak havoc on this whole thing. But this is what I'm going with right now. Okay? Okay, let's go over the test. And as usual, if you have something wrong, a question wrong, but you have work that's essentially correct, let me know. Take a look. Possible. Oh, Jim. This is you.
Thank you.
Okay, so let's go through it. And then I'll start sequences today. Okay, 1 through 5. We've got integrate each. First one is the integral 0 to 1 x e to the x dx. Obviously an integration by parts problem. You want to let u equal x. You want the dv equal e to the x dx. The du is dx. The v is e to the x. The integral is uv minus the integral of v du. Okay. X e to the x minus e to the x from 0 to 1. Put in a 1, you get 1e minus e, those cancel, minus 0, minus minus plus e to the 0, which is 1. Okay? All right, I'm just going to go right through this until somebody stops me, okay? Number 2, x sine x And again, integration by parts, u is x, dv is sine x dx. The du is dx. The v, the integral of sine, negative cosine x. The integral becomes uv minus the integral of v du. This minus with this minus gives you a plus. Integrate cosine to get sine, 0 to pi over 2. Okay. Substitute in pi over 2, you get negative pi over 2, but the cosine of pi over 2 is 0, plus sine of pi over 2, which is 1, minus, plus, but you get a 0 here or a 0 here. The answer is 1. 3, natural log x. Natural log x, many of the transcendental functions, natural log, inverse tangent, inverse sine, those are also integration by parts problems. Let u equal natural log x, dv is dx. The du is 1 over x dx. The v is equal to x. This integral becomes uv minus the integral of v du. The x's cancel out. The integral is just plain x from 1 to e. Substitute in e, you get e natural log e. Natural log of e is 1, so you get e here, but you get e here, so those cancel out. Minus, substitute in 1. The natural log of 1 is 0. That's gone. Minus, plus 1. The answer is 1. Whoa, is there a trend here or what? Okay, 4. Sine squared. Well, if you were surprised by that, you weren't listening, because I telegraphed that pretty much, it seems to me. Sine squared. How do you do the integral of sine squared? You need a half angle substitution. It's 1/2 the integral, 0 to pi over 2, 1 minus cosine 2x. So that's 1/2. Integral of 1 dx is x minus. When you integrate cosine 2x, it's a cosine u form. U is 2x, du is 2 dx. Multiply by 2 and by 1/2. You get 1/2 cosine u. The integral of cosine u is sine u. From 0 to pi over 2. And you end up with a 1/2. You put in pi over 2. When you put in pi over 2 for x here, you get 2 times sine, pi over 2. The 2's cancel. You get sine of pi. That's 0. Put in 0 to get 0, 0 to get 0. You end up with pi over 4. Okay. Number 5. Sine cubed. Sine cubed, what you do is split off one of the sines, leaving you a sine squared. Take those sine squares, change them to cosines. Pythagorean identity there. And then integrate each of these. That gives you the integral of sine, which is negative cosine, minus, this is a u to the n form. U is cosine, the du is negative sine. Multiply by -1 and -1. That'll give you a plus. Okay. U squared du. So it's u cubed over 3. Okay. 0 to pi over 2. Substitute in pi over 2, the cosine of pi over 2. The cosine of pi over 2 is 0. Cosine of pi over 2 is 0 minus plus cosine of 0, which is 1, minus 1/3, which gives you 2/3. Okay. Any questions on those? Nice. Very nice. Very, very nice. Okay. Let's go on. 6. Appropriate trig substitution for the integral of 9 minus x squared. 5. Go ahead. You got it all there?
Yeah.
We see. You put D. What the heck did you do that for? Ah. Let me give it a hand.
not have all the work right for 2 up until some sort of silly
Glitch.
math error going on. I think I didn't really understand what I did to make it equal 0. Did I get a ways wrong?
Integral cosine is sine. You got that right. I'll give you half of that.
I didn't know.
Okay, that was good. That was good. Looks all good. I don't know what you did at the end there. But. Okay, number 6. The substitution is to let x equal sine theta, 3 sine theta. Okay. So that when you substitute it in, you get 9 minus 9 sine squared. Take a 9 out. 1 minus sine squared is cosine squared. 7. 9 plus x squared. Let x equal 3 tangent theta. For the same reason, you end up with a tangent squared plus 1. And x squared minus 9. Let x equal 3 secant theta. Okay. All right, 9 through 11. Find the sum of the constants. Number 9. X over x plus 1, x plus 2. You're going to have an a over x plus 1. You'll have a b over x plus 2. Let's solve for a by multiplying both sides by x plus 1. Let x equal negative 1. Negative 1. Negative 1 plus 2 is 1. That's a. Solve for b. Multiply by x plus 2. Let x equal negative 2. Negative 2. Negative 2 plus 1 is negative 1. b is 2. The sum of a plus b is 1. Okay? So that answer is 1. Number 10. We have the integral of x over x plus 1 squared and an x plus 2. Well, it's the same kind of thing, except now we have the repeated linear factor, so it gets an x plus 1, but we also have to take into account the possibility of an x plus 1 squared. Okay? We can't solve for a, but we can solve for b by multiplying through, but here's what we have. Okay? I'm going to multiply both sides by x plus 1 squared. Let x equal negative 1. Negative 1. Negative 1 plus 2. That will give us b. Because what happens here, b is the only thing standing. Everything else gets multiplied by 0. We can solve for c. Multiply by x plus 2. Let x equal negative 2. Negative 2. Negative 2 plus 1 is negative 1 squared is 1. That's c. c is negative 2. Now we can turn around and now solve for a. Realize that this numerator and denominator would have to get multiplied by x plus 1 and an x plus 2. This numerator and denominator would get multiplied by x plus 2. This numerator and denominator by x plus 1 squared. This will have an ax squared. This will have a cx squared. There won't be any x squares here. So a plus c is equal to the x squares I have on the left, which is 0. If c is negative 2, a has to be 2. Therefore, the sum of the constants is negative 1. Okay? Everybody okay? Okay, cool. 11. We have x over x squared plus 1, x plus 2. Okay, so we're going to take this x squared plus 1, x plus 2. This is an irreducible quadratic. It gets a linear factor, ax plus b. This linear factor gets a c. Okay, we can't solve for a and b, but we can solve for c. Multiply by x plus 2, let x equal negative 2. Negative 2. Negative 2 squared is 4 plus 1 is 5. That's c. Now, what would this get multiplied by? X plus 2. This gets multiplied by x squared plus 1. Numerator and denominator. We have an ax squared. We have a cx squared. We don't have any bx squared. We don't have any x squared here either. So a plus c is 0. If c is negative 2/5, a is 2/5. Let's solve for b. Multiply through by b. You'll have a 2b here. You'll have a c here. We don't have any constant here. That's 0. If C is negative 2/5, okay, 2B has to be 2/5 divided by 2. B is 1/5. The sum of the constants, A plus C plus B, is 1/5. Okay, that's the sum of the constants. Okay, everybody all set on that? Nice. 12 through, wait, Edwin, what? What's up?
I mean, I got C and D, but I didn't get A.
Oh, that's too bad. Shoot. All right, 12 through 15. The correct method of integration, 12. That's a u to the n form, where u is equal to natural log x, du is 1 over x dx. It's u squared du. Okay, u to the n. 13. That's a trig substitution form. Okay, that would be a secant substitution. 14. Integral of inverse sine is an integration by parts problem. 15, and that's clearly partial fractions. Okay. 16. Evaluate the limit. X goes to 0. We have e to the x minus 1 over x. Well, you look at the numerator is going to go to 0 as x goes to 0, because e to the 0 is 1. The denominator is going to 0. That's a 0 over 0 indeterminate form. We can use L'Hopital's. Take the derivative, take the derivative. Now, as x goes to 0, e to the x is going to go to 1. This is stuck at 1. That limit is 1. Okay. 17. Limit. X goes to infinity. X squared over e to the x. It's infinity over infinity, indeterminate form. I can use L'Hopital's. Take the derivative, take a derivative. Whoa, I still have infinity over infinity, indeterminate form. Take a derivative, take a derivative. Now I have 2 over something going to infinity. That limit is 0. 18 through 20. Oh, this series. I mean, what's that? Robbie?
Okay, but I don't know how I did it, but I did this much 2 times 1 over e times infinity, but
It's true. I mean, that's true. 2 times 1 over infinity. Ooh, that's what it is, really, which is 0. Well, I'll give you half credit.
okay. Thank you.
Okay. We have the improper integrals. Some people messed up on these. Shoot. All right, 18. The integral from 0 to 1, 1 over x squared dx. Okay, we're going from, we want this area. And the way to do that is to do this. Let's take the limit as a goes to 0 from the right, from a to 1, 1 over x squared. Okay, we're going to let a approach the 0. From the right, if the limit exists, the integral converges. If the limit does not exist, it diverges. So, it's the limit as a goes to 0. X to the negative second. When you do that integral, add 1 and divide. I'm going to rewrite it as negative 1 over x. Okay. Okay, negative 1 over x. Just rewrite that thing. Now, substitute in 1 minus 1 over a. As a goes to 0, okay, a is heading towards 0. What's going on with this thing? It's increasing without bound. It goes to infinity. That means this diverges. Okay? Does the denominator go? Yes.
Wouldn't that be 1 minus a?
Say that again now.
Wouldn't that be 1 minus a? 1 over a?
1 over a. Oh, it's oh no, but it's minus. This, you put the 1 in, you get negative 1, and then it's minus. You know, when you evaluate the integral, f of b minus f of a, so that becomes plus. Yeah. The point is that it wouldn't matter if it's plus or minus. As long as a is going to go to 0, this thing is going to go to infinity, increase without bound, and diverge. Okay. 19. From 1 to infinity, 1 over x squared this is the second one we did in class. The infinity is making it improper. Okay, we have the same integral as before. It's x to the negative second. So you end up with a negative 1 over x again, from 1 to b. Substitute in b, minus, plus 1. As b goes to infinity, this is going to go to 0, and that's equal to 1, and that converges to 1. We did that one in class. And 20, from 1 to infinity, e to the opposite of x. Take the limit, b goes to infinity. E to the u form, u is the opposite of x, du is a negative 1 dx, multiplied by negative 1. So you end up with a negative 1 times the limit, b goes to infinity. It's e to the u form, so it's e to the u, from 1 to b. Okay, substitute in b, you get e to the negative b, e to the opposite of b, minus e to the negative first. Well, this is 1 over e to the b. As b goes to infinity, e to the b is going to go to infinity, but it's in the denominator. So that's going to go to 0. This will go to 1 over e, and hence converge. Okay. And that's that. Okay? I'll give you these at the end.
My test right there.
Yes. Okay? We all set on those? Let's do, and I also have the schedule for the rest of the semester here. So I'll give you these too. Let's go to 9.1 on sequences.
Can you split the recording?
We're still recording, right? Yeah.
Yeah, but can we split it up?
Well, you want me to stop it now and then split it?
If we